This video covers calculating the deciles, percentiles, and quartiles. So, in the previous video, we have seen the formulas and uh, uh, percentages, how to calculate, or quartiles to calculate it, and the steps for group data and ungrouped data. Just I'll recap the formulas. So, these are the formulas which displaying on the screen, and k into n plus 1 by 2, or k into n plus 1 by 4, or just directly taking the 4 quarters. Generally, we don't do the fourth quarter, just Q1, Q2, Q3 we identify, which is 25th value, 50th value, and 75th value of the quartiles. We'll do it. What is a range is displaying in which quarter. For that purpose, we do it. These are for ungrouped data steps, and grouped data NK by 100 minus CF, cumulative frequency by F into H, and plus L is a lower frequency for the grouped data to find out. Now let's jump into the example. How do we calculate the quartiles? So, for example, if we wanted to do it, quartiles, there are generally two methods to calculate the quartiles. One is through the formula method, and one is through the split method. Split method is used if the data set is in small number with below 10 digit or 12 digit maximum, where you can't, if you have a data set is given 100, it is very difficult to split into 50-50 and divide, multiply upper and lower. All these is difficult. Generally, preferably, if the data set is small, you go to the split method. Otherwise, you use the formula method. Let's go with the quartiles. And there is a step in our identification of quartiles, interpolation, where interpolation will have a formula. And in this video, I am covering only for the ungrouped data, and grouped data will cover in the later part. So let's take the example of this. So now the data set, the formula is k into n plus 1 by 4, or you can use q1 is equal to whichever we have discussed in our session, 3n plus 1 by 2, or n plus 1 by 2, or 3 by 4 n plus by 4. These are the q1, q2, q3 formulas. Or else you can just use k into n plus 1 by 4. N is your data set value, number of values in your data set, and k can be referring, when you are doing q1, you will represent k is equal to 1. When you are doing q2, represent with 2, and q3 means represent with 3. You do it, and that's how you find out q1, q2, q3. When the value of q1, q2, q3, one of them value is in points, you will try to do the linear interpolation. Linear interpolation, what is a formula? L plus p into L plus in the brackets p minus p is nothing but quartile position, where the position lying between, and minus f by f, small f and capital F. Capital F is an accumulative frequency of the previous data if it is a class interval. But how for this it is, I will show it. And small f is difference between the next two values, between the position wherever it is coming, and the class interval with is h. Whereas for the ungrouped data, how h and f are taken into consideration, I'll explain this example. Now, if your data set, for even data set, it comes into different way, and for odd data set, the data comes into the different data. Now let's and we as we understood these formulas on the uh, quartiles to calculate. Now let's move on to the with the example, and how are the values to be taken can be considered. For example, here 3, 6, 9, 12, 15, 18, 21, and 24, 27. When you count these numbers, the n value is odd. So for n value odd, how do we do it? For if the value is even, how do you do it? Is a question here. So you do it for median value, just you will take two middle values and do by 2. And if it is an odd value, the middle value will become your odd value. But if the point decimal value comes for your q1, q2, q3 quartiles, then only interpolation should come. So this is about the quartiles. Let's understand now. N is odd. So now first method is our formula method, whereas we have a different formula for k into n plus 1 by 100. K is, when you are calculating, K is Q1, K becomes 1, and for Q2, Q2 becomes 1. So n value is 9, which is number of values, which is 9. Just calculate, you will have 2.5, 5, and 7.5. Now you have got quartiles, Q1, Q2, Q3. Now what is this 2.5 and 7.5? Whenever you have any decimal value, you have to calculate the interpolation. Interpolation, how to calculate? Now the formula for interpolation is L plus P into P minus F by capital F by small f into H. So we know this formula, but how do you define this? This is an important thing. But substituting the values is easy, but identifying what is Q value, what is a P value, what is F value is important. Now let's take example of Q1 is 2.5. In 2.5, so second position, between second and third, 2.5 lies. So what is your second position of 2.5? So 1, 2. So between 6 and 9. So 6 becomes your lower value, and 9 minus 6 becomes your F, small f value, and capital F will become C, 2.5. This is a tricky here. 2.5 is there, no? Your Q1. 2 becomes your capital F. 0.5 becomes your H. For a non-grouped data, you have to know this value. What is our formula for interpolation? So L plus bracket open position minus capital F by small f into H. Now you got all values. L value is 6. Capital F is nothing but your 2, which is from your Q1 value. You calculated Q1 value, K into N plus 1 by 2. So you got that value. F is nothing but your index before the L. Nothing but you just ignore this index before L because it is confusing. Whatever the value you got, that capital F is 2 and 0.5 after the decimal becomes your H. So this is the you have to put small f is nothing but the values between the positions whichever are there. 2.5 lies between the values, not between the values, between the position second and third. So second and third are 9 and 6 and 9. So 9 minus 6 is 3. So higher minus lower value you will do it and you will get the value. So next comes the Q2. Q2 you did K in place of K, you substituted 2 and you got 5. So whenever the decimal value is not there, it is easy. Exactly, you just take the position of 5 and put it as your Q2 value. So in our data set, what is the position of the fifth position? 1, 2, 3, 4, 5. 15 is your position. So Q2 value will becomes the 15. So Q2 value becomes 15, and Q3, next to Q3 is nothing but we have got K in the place of K, you substituted 3 and 3 into N plus 1 by 2, you got 7.5. Now 7.5, this is how you have to interpret what values. So 7.5 means seventh position, between seventh and eighth position. What is your seventh and position? 3, 6, 7, 8. Between 21 and 24, you are 7.5 lies. So 21 becomes your lowell, and small f becomes your what is that? Small f becomes your 24 minus 21, which is 3, and capital F becomes 7.5. 7 becomes your capital F, and H becomes the 0.5. So now substitute the value for interpretation and just get the 22. Just use the calculator because you are allowed to use the calculator. And Q1, Q2, Q3, you got it. Q2 is a direct value. Just to take the position with the value. So now you got Q1, Q2, Q3, and this is how you calculate the quartiles for the ungrouped data, which is of odd data set. Now next comes the splitting method, which is median. Splitting method, directly median. Median means in a Q2. Generally 50 is your median, right? Middle value. So first you will calculate median 15. How did we get Q2 as 15? So out of 9, since 9 is median, so what is that? In between 9 number is, what is the number? Fifth digit. So 5 will become your fifth value, will become your Q2. What is your fifth value in your data set? Just count that fifth value, you will get. What is the data set we have given here? So it becomes, this becomes your fifth value. So directly you got 15 as in your median value, which is Q2. And next comes your Q1. So here is a split method. without including of 15, the set before 15 is taken as an a lower half, and a set after 15 is taken as an upper half. So divide. So your data set is divided into the two parts, whereas median is equal to taken as a middle number, and your data set, you can ask the question, if it is an even data set, how do you do it? So you do it with the one inclusive of one data, two values you will have, no, you'll split. I have depicted that example also below, will explain. So before these values, these four becomes your lower half, and this becomes your upper half. So that's how split method is used. Generally, if more data set, bigger data set is given, this split method is not used. Then now you divide. Now here you have the even data set. So even data set, you will have to add two values, which is 6 plus 9 by 2. That means Q2 is 7.5. Upper value, after 15, the upper value in the data set, you take it. Here also the even digit. So 21 plus 24, you were getting the value of 22.5. So if you observe, either you do it in the splitting method or you do in the formula method, the Q1, Q2, Q3 values are similar or almost the same. 7.5, 15, 22.5. Here also you have the same values, 15, 7.5 and 22.5. Okay, this is for the split method, which is for the quartiles. Next comes the even data set. When original even data set is given, originally the data set is given in the above example order. Now you have even data set. So same formula, find the Q1, Q2, Q3. Q1 is n plus 1, where k is equal to 1. So you use the Q1, Q2, Q3, and you got 2.75, 5.5, 8.25. All three values are you have in decimal values. When you have decimal values, what is the how do you do it? You have to find out the interpolation formula, you know it. Now just what you have to do it. Now you know the values interpretation. 2.75 means in your data set, go to your data set, which wherever you have second position between 8 and 12. And 5.5 means fifth position, 1 2 3 4 5, between 20 and 25, 20 and 24. And 8.5, 1 2 3 4 5 6 7 8, 8.1 2 3 6 7 8 9, between 32 and 36, 8.25 comes. So now just you got the values, and just where it flies. Now you know previously how you substituted. 2.7 means 2 becomes your capital F, 0.7 becomes 75 becomes your H, and small f is difference of your 2.75, which lies in between the values of 12 and between 8 and 12, which is almost a second to third position. So 12 minus 5 becomes small f, and L becomes a lower value, which is 8, and substitute the values using the calculator, get the values. And similarly 5.5, which I told 24 between comes between fifth position to sixth position, and the small f, H, L, 5.5 zero point 0.5 becomes your H, and before 0.5 value becomes your what is that, capital F value. And Q3 also similar, it comes between the 8th and 9th, 36 and 32, 32 and 36. You identify the values and you get that Q1, Q2, Q3 values. The same thing, use the split method. Only difference you will get here is in split method, median is not directly, earlier in the split method directly you got the value, middle value as 15, whereas here you will take two values plus by 2. But when you split it, the you splitting here earlier, leaving 15, you got the 15 as a middle value. When the 9 digits are given, you exclusive of 15, you made one bucket, and the other bucket exclusive of the 15 value. Here the splitting should be happening, first digit should be including in the lower limit. Example, here you have where is our data set? Here our data set includes 20 plus 4, two values we got it, right? So So till 24, inclusive of 20 will become the lower set, and inclusive of 24, two values, right? 24 will become the upper value set. So two data sets, it should be inclusive. In your odd data set, you don't include that in the split method. So that is only difference, and you will identify the middle value with two middle values divided by 2. That's all. That these are the two differences. Then it is easy Q1 to find out when you are lower half. What is a middle value? It is simply, and middle value is 12. If it is, this is a odd data set, it became. So you have a middle value 12. Whereas in earlier, this middle value become our even data set. So you have to do two middle values divided by 2. Here it is again, data set is odd value, and the middle value becomes easy. No need to do it, and two numbers divided by 2. So now you have got Q1, Q2, Q3. It's the same thing for both the values, which we got it in the split method and which you got it in the quartile method. That's about the quartiles. Next topic of ours is, after quartiles, we read through the percentiles in the previous video, where in the percentiles you have 100%. A percentage can be calculated. P70 can be given, P40 it can be calculated, or P50 it can be calculated, etc. can be calculated. Now let's see how to use for group data and ungrouped data with the examples, how to calculate the percentiles, and how to use the interpolation, for which data we have to do the interpolation, etc. we'll use. Now let's do for ungrouped data. Again, the data set is given where n value is 10. Generally, most of the values are in ascending order. In case if they are not there, put it in the ascending order. And our formula for the percentage is LP is equal to P into n plus 1 by 100, which we have done in your previous classes for ungrouped data. P value is nothing but, here it is asking for 30th percentile. So in your question itself, 30th. So P becomes your 30. N is your number of data set. So do that 3.3. Again, interpret whenever you have any decimal value, interpretation. That earlier interpretation value is calculated with L plus P minus capital F by small f into H, whereas here you have a different formula. So now let's understand how the interpretation is the same thing. 3.3, where this 3.3 comes, you just need to understand between third and fourth value. What are third and fourth value of your data set? 15 and 20. So third and 15 and 20 value. So third value is 50 and fourth value is 20. Now 3.0.3 is your interpreter. Now interpretation problem is third value, fifth lowest value into decimal value into L minus lower bound minus upper bound minus lower value. That becomes the interpretation. So 16.5. So your P30 becomes your 6.530. And similarly, second example with the data set n is equal to 10, and same formula 40, and between the values you do that. It is a similar problem. Similar, just here you are identifying the 40th value. There in the previous example, you use the 30th example, and here you will use the 40 into n plus 1 by 100. Then where when you say 4.5 means it between the fourth value and fifth value. What is the fourth value in your data set you should bring, and what is the fifth value, and substitute the formula. P40 is equal to lower plus point LP value into upper value minus lower value. We will become the P40 value. That is about for ungrouped data. Now let's come to the grouped data. So almost by this time, grouped data means frequency is given. When a frequency is given, if you are talking about median, percentiles, quartiles, anything except means, everything must except means and modes, you have to have a cumulative frequency. So cumulative frequency, you are aware, the same number remains, and the next number is divided by 5 plus 8 becomes 13, 13 plus 12 becomes 25, 25 plus 15 becomes 40, 40 plus 10 becomes 50, and summation of this value of n becomes the 50. So that's first total observations is n. In the previous formulas, only data set is taken. Whenever the class frequency, class interval, etc. are given, you have to use the summation of fi, not summation, only the data set numbers. So now LP is equal to P into N plus summation of N plus total number of values divided by, just substitute, you will get 15.3. Now here in the class interval, you have to see the cumulative frequency where the 15 value can come. It cannot come under 13. It can come under 25. So the corresponding class interval L becomes 20 and upper becomes the 20 and 30. So now substitute the value of your percentile. We know that L plus K into N by 100 minus F by F into F. So now apply the formula. Lower class boundary is 20, K is equal to 30 because it is asked 30, P30 value, and N summation of Fi is 12, and the frequency, cumulative frequency is always the cumulative frequency is always here, but if the value whichever class interval is coming here on the above is your cumulative frequency. In median, how do you calculate? The highest frequency above line is your considered as a small f, whereas here above the you got the value as 15.5, right? While calculating, how, where does that class 15.5 comes? Here under 25. So the above, the corresponding class interval above line 13 is taken as F. So this is a trick and not trick, basically. It's a way to calculate the values of the certain values. So F becomes 13, and just substitute the values and use the calculator and put the values into this, and your value comes as percentile is equal to 21.92. So that's about the percentiles. Next comes our chapter. Third example is with deciles. Deciles are nothing but which are coming into an 10 parts. You divide the all everything into 10 parts. First part becomes 10%, 20%, 30%, which you have done. And how to do it? Yeah, arrange them into equal parts, ascending order, all these. It remains the same. K into N plus 1 by 10, the formula comes, and if you are dividing 50th percent, your value will become D5. And similarly, if it is an integer value, if it is a decimal value, you have an interpolation different formula where you have to use this formula here for interpolation whenever you have the decimal value. For a grouped data, again the previous value, how you have cumulative frequency, similar formula you has to use, but different one. Dk is equal to L plus K into N by 10 minus Cf, cumulative frequency, previous value divided by small f into H. H is your class width and F is your frequency of the decile class. Okay, let's go with the example now. So the deciles for group data and ungrouped data will catch up in this. So deciles for the ungrouped data, that data set is given, and it is asking 50th percentile, which is median. Arrange in ascending order, and D5 value you pick it up. Which is D5 is nothing but your value become K value becomes 5, N plus 1 by 100, which is our formula. Calculate LP is equal to 5.5. Now, whenever you have a decimal, you have to interpolate. So 5.5 means it becomes between fifth to sixth value, which we have done in your quartiles. The position becomes fifth to sixth. So now what is your fifth value and sixth value? Just count the positions, which becomes your 20 and 25 and 30. So 1, 2, 3. Where is your position? Sorry. 1, 2, 3, 4, 5. So between 5.5, meaning between fifth and sixth, your position will become. So fifth value is 25 and sixth value is 30. Just interpolation x1 plus x2, which are 25 plus 20, 30, and divided by 2, you will get the decimal value. So that's about the calculating the decile for the decimal position. Sorry, I'm too fast in this. Okay. N is your total number and you will substitute the value, and we have put 25 and 30. And interpolation is when the position is in integer, this value. When it is a decimal, different formula. Just put that and you will get it. Now decimal position. Now next example is with the decimal example. Arrange the ascending order, all the data, and it is asking 70th percentile. So your k becomes the 7. You just 7 into n plus 1 by 100. N value is here. What is your n value? 11 are given. So 11 it becomes, sorry, 10 only. 10 plus 1 becomes 11. So 7.7. Now between 7th and 8th position, what is your value? Data set you have to see. In your data set, what is your 7th? 44 and 50 is your 7th and 8th between. So you take the 7th value 44 and 50 and interpolate it. For decimal, this is a different formula, LP minus lower position into difference between two values. Whereas earlier you have used x1 plus x2, which is lower bound and higher bound by divided by 2. That is for non-decimal, which is in the above example which I shown. This is the formula where, let me go, x1 plus x2 by 2, dk is equal to, when the value is exactly average of two things you do. When it is in a decimal value, your LP value interpretation will change. Whereas in quartiles, the formula remained the same, whether irrespective of the uh, decimal value. Whereas it, because you are calculating median there, if it is no decimal, you don't go for an interpolation only in quartiles. So that's a difference you should catch here. And so you substitute the values. LP, 7.7, and lower bound is 44, and just for, and 7.5, 7.7 minus 7. 7 is your what is the value for 7? You got 7 is 7.7 is your H, and 7 is your lower bound value. Just to substitute that, you will get that value. Okay, this is for the deciles. With this, we completed quartiles, and percentiles, and almost in central averages or measures of central tendency, we completed all examples. Wherever the examples are not covered, like in your assume method in the mean, and here in the quartiles, I did not show the example for the grouped data. Some missing here and there, some missing problems are there. I'll cover it in the last video, which covers the entire chapter, which is called measures of central tendency. With this, most of the 99% of the central averages chapter is covered.